Okay, good morning. Let's continue with the prefixes. Okay, prefixes. Prefixes are really important in physics because these prefixes are the way of making notation for some of our units when we don't want to express all the zeros and like this. This is the following way. We see that there is the base. The base is our unit. For example, it can be meter, can be pascals, it can be, I don't know, maybe Kelvin, and whatever. It's the base. It's basically our unit. When we are talking about prefixes, we see that there are many. For example, there are some that they make the unit bigger. Something interesting to see is that any of these of the prefixes that make bigger the unit, if we see all the first letters, their symbol is a capital letter. This means that if we see a symbol with a capital letter, this means that actually this prefix is going to make bigger our unit. Okay, then for example, if we want to make the unit smaller, like in these cases, we see that the first letter is always in lowercase letter, except the only exception is this micro, where we use the mu Greek letter. Okay, we have the prefixes that are these: iota, zeta, hexa, peta, tera, giga, mega, kilo, hecto, deca. The base, then deci, centi, milli, micro, nano, pico, femto, atto, septo, y yocto. Okay. What is really important is to know how much are we incrementing or decrementing our units. For example, let's take into account giga. Maybe giga, we have listened a lot, gigabytes, something like this for computers, right? We also use it a lot in physics. For example, can be gigapascals. That's a really common unit that we have for when we are talking about resistance of materials. Okay. This, when we have 5 gigapascals, this means that actually we have 5 times 1 times 10 to the 9 power. This means that this one will have actually 9 zeros. That's what this exponential means, the number of zeros that we have to increment, or also it says the number of jumps that, for example, this 0.5, 0, 1, 2, 3, and like that. 4, 5, 6, 7, 8, 9. Okay, this is what this exponential means. We have to learn them by heart, or at least know how to use the tables. That's for the ones that make them bigger. But for example, when we have, for example, 5 nanoseconds. Okay, 5 nanoseconds is telling us kind of the same. 5 times 1, 10 to the minus 9. This means that we are going to have 5 times 10 to the minus 9, or that if we have 5 and the point here, remember, if the exponent is positive, we move the point to the right. And when we have a negative one, we move the point 9 times to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we will have actually Okay, this is 1, 2, 3, 4, 5, 6, 7, 8 zeros and a 5. That's because we move 9 times to the left. Remember, that happens when we have an exponential that is negative.